you should buy a faster CPU. What is so? Someone last week, who was it last week? Howard John's blog last week said in the past few years, CPU's gotten really fast, shockingly fast. Yet most people are stuck on previous generations of mobile chips, whether by choice or by their company's choice. So if you work for a company and you have a laptop, like a company laptop, they will just give you a piece of hardware and you'll be stuck with it for a long time. And so that's usually why old hardware sticks around. Or in my case, by choice, I'm actually running on a pretty old laptop myself right now, streaming over YouTube with this old laptop, which works perfectly fine. It works perfectly fine, as you can see right now. So I'm kind of like the by choice category at this moment. So this might be a reason to upgrade and so it says it's at a huge detriment to my productivity, and I don't think so. Right now, I don't agree. My CPU is pretty darn old now at this point, and it still does what it needs to do. Meanwhile, AI coding subscriptions like Cursor are all the rage these days. I'll skip the debate on exactly how useful these tools are, of course, and focus on pricing. Okay, so here's what John Howard's gonna do. He's gonna compare Cursor's $480 a year for a team plan with the cheapest corporate plan, and he's probably going to compare it to the price of a CPU. And that's exactly what's happening here. That's what the argument is. Cursor, $480 per year. Engineering productivity is worth at least $500 per year. In terms of these AI code generators, you can get some gains on productivity. This makes sense. It's given the typical salary of a senior US-based software engineer. You don't even need to be 1% more efficient. That's a good point. That's a really good point. Okay, so I actually take a step back here. This argument actually kind of makes a lot of sense if we're really looking at it. So take a peek here. Check this out. So they're saying, based on the salary and the net benefit that you have, a 1% efficiency boost is worth the investment, even at $500. If you get even if you get 1% efficiency boost, just one, you only need 1%, and they're saying that you get that with Claude Code or OPEC or Codex or Gemini CLI, you name it. That's actually kind of cool. That's actually really good. That's a really good argument. So with that 1% improvement, do you get the same level of efficiency of developer productivity improvement if you buy a Ryzen 9 99050X, which is only $500? So practically speaking, it'll last longer. So sure, right? So I can't believe that chip is only $500. Is it really? So it's a really fast. It's a top of the line CPU. It's only $500, and it will last you multiple years. So you're not really spending the same price that you're spending on, say, Claude Code, right? Or Cursor, which is $480. If you buy the CPU at $500, it'll last multiple years. So that'll make it like, your machine's amortizing the cost of the machine over $170 per year. So that's like $200 per year. It's a bargain. Do you get 1%? Do you get 1% net efficiency gain with a CPU like that? I don't know, but John Howard said, yes, buy the fast CPU. It's well worth it. It's okay. So here's more arguments. Below show some benchmarks for 3 machines. The fastest laptop my former employee would give me in 2024 was an Intel processor released in 2020. My employer clearly didn't follow my advice to give top engineers the top CPUs. Okay, sure. I guess there's an argument there. The fastest ThinkPad I could buy in 2024 was a Ryzen 7840U. Okay. The fastest desktop CPU in 2025 is the Ryzen. So, okay, here we go. Oh, well, we don't compile Linux all the time. How often do you compile Linux? I suppose depending on the kind of engineer, if you need to be compiling an operating system, yeah. But you wouldn't be using your workstation CPU. You'd be using a cloud infrastructure CPU. This you would just lease the compute. This is what I do. Like I have a really old generation system currently running right now, that's streaming to you. And what we're looking at here is the argument saying that your workstation CPU should be at, because Linux compiles faster. Look, you're not going to be, you might not compile Linux on your local machine. You just might use a cloud server. That's what my argument is. And that's what I do. That's what my argument is. You just lease an hour or two of the CPU to build the binary that you need, and then you download the binary and you're good to go. But that's the argument here. So I'm still thinking, and the same for OpenSSL, right? So there's an OpenSSL benchmark. You don't need that much power on your workstation. You don't need to transmit that much data encrypted on your system. You just don't. It's just not something you need. If you need that much power, you could just lease a compute, right? Lease a modern CPU in a cloud provider like Google Cloud or Azure or AWS. Just do that. Just lease your compute there. There's no need for you to buy this as your local machine. To be fair, though, it is really nice. It would be really nice to have that kind of horsepower in your machine. I cannot argue it's sort of like nice convenience. I don't know. It's more satisfaction or happiness. I don't know how you attribute it. Is it worth it at that point? In this case, the only thing I can see to have an argument here in this case is your just happiness, or your as a human, your satisfaction. I do not have any agreement on the consideration for productivity improvements, because if you need this kind of power to do these kinds of tasks, you just rent a server temporarily. All the cloud providers lease to you compute on a per second basis. So you just lease a super giant CPU that might have like 200 cores, and then have it do work for you in a minute or two, and then you download the result. Like, you don't need to do TLS benchmarking on your laptop, for example. The gap here is incredible. Over a 10x difference in many cases. The difference between waiting 3 seconds versus 30 seconds is game-changing. Yeah. I mean, really? So I can see that the CUD makes sense if this is what you're doing. Most people are not building Linux, though. So as a general rule of thumb, desktop CPUs are about 3x faster than laptop CPUs. Oh, okay. Top-end CPUs are about 3 times faster than the comparable top-end models 3 years ago. Okay. This applies to cloud VMs as well. Each new generations are 2 to 3 times faster, many workloads, and usually the same price. How much money would you be spending on a server versus, spending it locally on your own electricity? It's tough to say. But in this case, here's what I do. Here's what I'm doing right now. I have an older system, and whenever I need this much capability or this much throughput or this much power, I just quickly lease for a couple of minutes a really big machine, have it do my work for me, and then download it, and I'm done. And that way, I don't have to burden my machine with any of that workload, and I get to swift off onto some other tasks, and I'm good to go. So at least that's my thoughts from this perspective. Don't get me wrong, it would be nice. It'd be really nice to have an AMD Ryzen